In this video I'll be looking at the solution to question 2 of the January 2010 Edexcel M1 paper, and the topic of the question is kinematics. In the question we're told that an athlete runs along a straight road. She starts from rest and moves with constant acceleration for 5 seconds, reaching a speed of 8 meters per second. The speed is then maintained for t seconds until she decides to decelerate at a constant rate until she stops. She has run a total of 500 meters in 75 seconds. In part A of the question, we're asked to sketch a speed-time graph to illustrate the motion, and then, having done that, in part B, to calculate the value of t. Okay, so taking part A first of all, we have the athlete is running along a straight road and she starts from rest with a constant acceleration. So this is going to be a straight line from the origin rising at a constant gradient until she's got to a value of 8 meters per second for her speed, and that took 5 seconds. That's then maintained, so we then have a horizontal line for some unknown time, capital T, in which afterwards she then decelerates at a constant deceleration. So putting some values onto the graph as drawn then, the first part here, the time is 5 and the speed reached is 8. We then have a time of t seconds along here, so that the time to reach the point where the deceleration starts is t plus 5. And we're also told then at the end of that motion it is taken a total of 75 seconds. The marking for that was a lot of B marks which don't require any particular method. There was one for getting both of the first 2 sections of the graph correct shape, and then a second B mark for the third part of the graph, and a third B mark for the labels on these axes. The second part of the question then goes on from there and asks us to calculate the time t. Now, the other piece of information that we've been told is that she runs a total of 500 meters. So we need to use the fact that the distance travelled in this case is going to be the area underneath the graph. So the area under the graph is going to be equal to 500. Well, treating this as a trapezium, that area is 1/2 the sum of the parallel sides, that's capital T, plus 75, multiplied by the distance between them, or in other words the height, which is the speed 8, and that's equal to 500. Well, multiplying up by 2 and then multiplying out the 8 into the bracket, or alternatively doing it by cancelling the 2 and the 8 to give you 4. Whichever way you do will lead eventually to an answer of t is equal to 50 seconds. The mark allocation for this part of the question, there were 5 marks in total. A method mark for using the area under the graph as being equal to 500, and then 2 A marks for correctly getting the formula for the trapezium, and then finally a method mark and answer mark for solving to get t. Well, that's the end of that solution. There are solutions to other questions from this module, and indeed other modules that can be found on www.furthermaths.org.uk.